Dalton's law tells us that the total pressure of a gas mixture is equal to the sum of the partial pressures of the individual components. So let's take a look at this in sort of a real world example. So if we look at the atmospheric pressure, it is equal to about 760 millimeters of mercury at sea level, right? And that is because it's the sum of the gases, partial pressures that the gases exert, which are a variant of their overall percentage or composition of that air. So it is the pressure, the partial pressure, is dictated by the fractional composition of the different gases. So we can say that 79% is nitrogen, we have 21% oxygen, and we have 0.03% carbon dioxide, and that is sort of our overall composition of the atmospheric air, right? So if we do that and we say, okay, well, 79% of it is nitrogen, we can do 0.79 times 760 millimeters of mercury, which gives us a partial pressure of 600.7 millimeters of mercury. If we say, okay, O2 is 21%, we can do the 0.21 times 760 millimeters of mercury is equal to 159 millimeters of mercury. If we look at CO2, we can do the 0.0003 times 760 millimeters of mercury is equal to 0.23 millimeters of mercury. And that tells us the individual partial pressures of atmospheric air. But what if we were to look at sort of our Mount Everest? Remember that the atmospheric pressure at Mount Everest is different. So if we look at atmospheric pressure at the top of Everest, it is equal to 250 millimeters of mercury. The composition of gas, or the fractional composition, is the same as it was at sea level. So if we look at individual partial pressures, we look at nitrogen, that is going to be 0.79 times 250, which is equal to 197.5 millimeters of mercury. If we look at oxygen, right, we do our 0.21 times 250 millimeters of mercury. That gives us 52 millimeters of mercury. So look at your partial pressure of oxygen at Mount Everest versus your partial pressure of oxygen at sea level. So if we look at how gas exchange is supposed to occur between compartment A and compartment B, and it's supposed to move against its concentration or partial pressure gradient, if our partial pressure here is 159, we have a very high partial pressure. But what if it's only 52? We don't have as strong as a pressure gradient for gas exchange to occur across that respiratory medium. So this is another reason why breathing or respiration at high elevations, like at the top of Mount Everest, is so difficult.